Hello, this is Ms. DB. In this video, we are going to look at how to do some of the problems from the Chapter 12, Section 1 worksheet. This is on reflections. So this is not a very long worksheet, and it won't take you very long to complete. First of all, we're going to learn about transformations in this chapter. So here are the first three that we're going to be working with. Reflection is when you transform a figure across a line. Each point and image will be the same distance from the line of reflection. A rotation is when you spin a figure, rotate a figure about a point. We will be using the origin as the point that we are going to rotate about. Each point and its image are the same distance from the central point. And also translation, that is when all the points of a figure move in the same direction. All of these three different kinds of transformations are called isometries. They do not change the size of the figure. So all three of these, the original figure and the new figure, are exactly the same shape and size. The original figure is called the pre-image. So in this one, the original is A, B, C, D. That's the pre-image. And after it has been transformed, in this case reflected, we would name this A prime, B prime, C prime, D prime. And that's called the image. So we have a pre-image and then we have an image. The coordinate points are, so in this first one, this reflection, A was reflected and transformed to A prime. So you use the same capital letters, but you put an apostrophe after it and you read that as prime. And we've talked about transformations a bit before. Way back in Chapter 1, we did some transformations with triangles, and there's some videos in the folder that we go over that, so you can start there. All right, so in the first section of the text, we're just working with reflections, and then there'll be other section 2 and 3 will be on translations and rotations. So to tell whether or not it's a reflection, you need to look and see if there's an invisible line in which you could fold this paper and you would get exactly the same thing on both sides. If that's true, then it's a reflection. So in A, it looks like this figure, this blue figure, was flipped over this line, and then you get the red figure. But in B, it does not look like it's been flipped. It looks like it's just been moved or translated. So for the first few problems, you just have to answer yes or no. But if you say no, say why it's not a reflection. Like, for example, in number 3, I would say no. This figure does not appear to be flipped. It appears to be moved or translated instead. So just yes or no, and there's 2 no's, and you can say why they are not a reflection. Then the next section is how to draw reflections. So if you're drawing by hand, you need a ruler to do these, and you need to do that carefully. So here's the definition of a reflection. It's a transformation across a line called the line of reflection, so that the line of reflection is the perpendicular bisector of each segment joining each point and its image. This is a very specific definition. We usually say that a reflection has been flipped over a line of reflection. You do need to know that we have a pre-image, which will be named, if it's a point, it's just named with one capital letter, and the image would be that same capital letter with the prime after it. So you would read this as A prime. If it's a figure, like a rectangle or a triangle, then each figure or each point, each vertex will be named with a capital letter, and after it has been reflected, then it would have the same capital letters but with primes after them. So if this is A, this would be A prime. You can show your reflections with dashed lines instead of solid, or with different colors. Those are good ways. Like our book uses 2 different colors to show the pre-image and its image. Remember, the pre-image is the one with no apostrophes after the capital letters. So you're going to go ahead and graph for 5, 6, 7, and 8. You're going to graph the pre-image and the image with the reflection over each of these axes. So over the y-axis, over the x-axis, over the x-axis, or over the line y equals x. Here's some rules here that will tell you how to do this. If you're going to reflect a point across the x-axis, and you would do this for each vertex of the object, all you do is keep the x coordinate exactly the same and change the sign of the y coordinate. So if it was positive, it changes to negative. If it was negative, it would change to positive. So the x coordinates stay the same, the y coordinates are opposite. That's what this tells you in symbols. To go across the y-axis, to reflect across the y-axis, you leave the y-coordinate the same, but the x-coordinate will be the opposite. So the opposite of the x-coordinate, and then the y-coordinates are the same. To reflect across the line y equals x, which is the diagonal line cutting this coordinate system in half this way, you flip the x and y coordinate around. Don't change either of their signs. The x coordinate becomes the y coordinate, and the y coordinate becomes the x coordinate. So you can graph these by hand if you've printed your worksheets out, but again, be careful. You're going to need the pre-image and the image. Label them correctly. Use a ruler. You can also make them in Word by going to Insert and then use the drawing tools or the Shapes menu in order to find the line segment and make them that way. It does take a little bit of mouse work to get them all lined up correctly. To do the rest of these, and that's it on the worksheet. There's only 8 problems, but these do take a little while to graph them. Thanks very much and have a wonderful day.